What if the main reason not to go to Mars isn't radiation, distance, or cost? What if the real danger is what we might find there? Not ancient artifacts, not traces of simple life. Something that would make us regret our very first step on red soil. Something that proves Mars isn't an invitation, it's a warning. This isn't science fiction. Right now, NASA and SpaceX are gearing up for missions in the 2030s. Engineers are turning blueprints into metal. Crews are going through selection. It's a race with the Martian horizon as the finish line. Humanity is putting everything on the line for the greatest adventure in its history, sending our finest sons and daughters into the unknown, and we're training them like no one before. Half a century ago, one program reset the bar for astronaut training. The Apollo astronauts. They weren't just pilots, they were almost superhuman. They learned to survive in jungles and deserts with nothing but a knife. They endured psychological trials that could break a special forces operator. Each man was engineer, scientist, and warrior all at once. They trained for every emergency the void of space could throw at them. Every emergency. Except one. On January 27, 1967, Apollo 1's capsule sat on the launch pad. 3 astronauts were inside. A pressurized atmosphere of pure oxygen filled the cabin. One stray spark. A fire that lasted only 17 seconds turned fatal. The most prepared people on the planet, the brightest minds of their generation, didn't die in space. They died on Earth because of a single design flaw no one had foreseen. This reveals one simple, chilling truth. Even the most skilled crew in the most advanced spacecraft can be undone by a single hidden flaw. We've learned to anticipate mechanical failures and human error, but how do you prepare for a fundamental defect built into the planet itself? The very world we're flying to? What if Mars beneath the first colonist's feet isn't solid ground but a fragile, unstable trap? This trap isn't just a hypothesis, it's real. And it's already sprung. Martian soil isn't solid. It trembles, constantly. Seismometers record non-stop Marsquakes, jolts that rattle the planet down to its very core. But these aren't the earthquakes we know, driven by shifting tectonic plates. Their source is a mystery. This is the shiver of a world that looked dead, but turned out to be frighteningly alive from the inside. And that trembling points to something far more troubling than ordinary geological activity. It points to a void. Seismic waves traveling through Mars behave oddly. They fade and warp, as if enormous underground cavities hide beneath the surface. That means we'd be building cities on a crust that looks like a giant slab of Swiss cheese. One Marsquake could be catastrophic, collapsing a colony's foundations into a yawning chasm. But fear is only one part of the story. The other is awe. These cavities aren't just empty voids. Billions of years ago, Mars was different. It had a thick atmosphere, rivers, and possibly oceans much like Earth's. Those caves could be the last refuge of that ancient world. Sealed time capsules holding frozen lakes, samples of ancient air, or maybe something more. We hunt for life on the surface, but it might be waiting below in the icy silence. All of it, a fragile, unstable crust that could be hiding the greatest discovery in history, comes together into a single picture. A picture of a world you can't handle with brute force. And yet, that's exactly what we're about to try. We don't just plan to land, we intend to remake the planet in our own image. But what if our attempt to bring Mars to life with the most destructive tools at our disposal destroys not only its secrets, but the only clue to our own origin? We've always been obsessed with one idea: remaking worlds. Not just visiting them, changing them, terraforming. The word belongs in science fiction. It also stands as the boldest expression of our ambition. Take a dead planet and breathe life into it. Turn an icy desert into a blooming garden. Mars is our chief target. We look at its red sands and don't see what it is. We see what it could be. Oceans under a blue sky, clouds, rain, a second Earth. And we already have a plan to make it happen. A plan that's as brilliant as it is a little mad. Forget slow, cautious approaches. Elon Musk's plan is planetary-scale shock therapy. No giant mirrors in orbit, no factories pumping out greenhouse gases for centuries, only raw, primordial force. His idea: drop thermonuclear bombs on Mars' poles. A series of blinding flashes make it brighter than 1,000 suns. mushroom clouds climbing above the ice caps. The blast would instantly vaporize billions of tons of frozen carbon dioxide and water, hurling them into the thin atmosphere. That, the theory goes, would set off a chain reaction, thickening the air and warming the planet. A new world, born in nuclear fire? A move this radical could have completely unpredictable consequences. The irony is sharp. In trying to bring Mars back to life, we might wipe out the single greatest clue to our own origins. There's a hypothesis called panspermia. It proposes that life on Earth didn't start here. It's an immigrant. Its original home could be Mars. Billions of years ago, when the red planet was young and wet, an asteroid strike might have blasted a chunk of Martian rock into space. That rock, carrying microscopic passengers, could have drifted for millions of years before crashing onto a young Earth. If that happened, then all of us would be, in a sense, descendants of Martians. And now we're preparing to bombard the place that might be our cradle, risking the erasure of every trace that could prove it. We build these grand plans from the data our robotic eyes send back as they crawl across the surface. We're sure we understand this world, but what if those eyes are looking in the wrong place? What if the picture of Mars we've painstakingly stitched together, piece by piece, is only a tiny fragment of a vast, unfathomable mosaic? Perseverance discovers something that looks like branching coral. Curiosity photographs a rock that could be a human femur. A Viking image from 1976 shows a giant face staring into space. Each time, the internet erupts. It looks like proof, but it isn't. Every time those images get explained away, light and shadow playing on oddly shaped stone. Pareidolia. Our brain's tendency to find familiar forms in random patterns. The real illusion isn't the rocks. The real illusion is our certainty that we're seeing anything at all. Every photo from Mars gives us a false sense of control. We receive crisp, detailed panoramas. Red dunes, craggy hills, dusty plains. The landscape starts to feel familiar. We begin to believe we understand the planet. But that's self-deception. We're peering at Mars through a keyhole and convincing ourselves we've seen the whole room. Imagine aliens studying Earth by sending one lone robotic turtle into the middle of the Sahara. It trundles a few miles, then sends back a report. Planet. Scorching sand. No life. An identical probe, dropping down in Antarctica, would report, planet, an icy wasteland. We do the same. We judge an entire world by a handful of tiny dots on its map. Over decades of exploration, all our rovers combined have driven a distance you could cover by car in a couple of hours. They've examined an area roughly the size of a small town, on a planet whose surface equals all of Earth's land. We don't know what's hiding over the next hill. We haven't seen 99.99% of this world. We're blind. As we peer at these deceptive images, hunting for ghosts and fossils, we're missing the most obvious real threat. It doesn't hide in caves. It doesn't wait in the shadows of rocks. It's everywhere, right under the wheels of our rovers. But what if the deadliest trap on Mars isn't what we're hoping to find? It's the ground we're about to walk on. Not cliffs, not caves, not even the Martian storms that could swallow whole continents. The biggest danger on Mars is what covers the planet everywhere. Tiny, omnipresent, reddish dust. It's in the air we can't see. It's on the ground we plan to step on. Billions of years of erosion, radiation, and chemistry forged a material we barely understand. That quiet unknown is more frightening than any obvious threat. We've met a similar enemy before, and it nearly beat us. Apollo astronauts prepared for almost everything except lunar soil. They came back aboard and they brought lunar dust into the cabin. It wasn't soft, familiar sand. Under a microscope, those grains looked like shards of broken glass. Billions of microscopic blades, never rounded by wind or water. This dust showed no mercy. It gummed up suit zippers and fasteners, rendering them useless metal. It scored helmet visors, leaving them cloudy. It ground down seals and raised the real risk of depressurization. Mechanisms engineered for vacuum and extreme temperatures failed after contact with what looked like ordinary dirt. Millions of dollars worth of equipment wore away under an invisible abrasive. But the worst damage happened inside the spacecraft. In microgravity, razor-sharp particles simply hung in the air. Astronauts breathed them in. The result, severe respiratory reactions. Coughing, burning eyes, damaged lungs. They called it lunar hay fever. It became the first extraterrestrial disease in history. Even the bodies of the most prepared people on Earth reacted to the alien substance as if it were a poison. Here's the final bone-chilling paradox. We had at least some familiarity with lunar dust. Martian dust, though, is a complete unknown. We travel 300 million kilometers to set foot on a world blanketed by a substance we don't understand. One that could be far more abrasive, far more toxic. In our arrogance chasing signs of life, we risk becoming its executioners. Our machines, our suits, our lungs, they'll all carry that dust. It could destroy us, and it could erase any fragile Martian biosphere. We came as explorers. We may go down in history as sterilizers, and the greatest discovery on Mars might be the realization that we never should have gone.